So we have a really exciting test that you just completed, Steve. We were able to take some of the greatest lighting fixtures that we've found for vegetative growth, or blue spectrum enhancement for, let's say, full spectrum capability, and we tested them against each other. Now, Monster Gardens has been a plasma tester from the very beginning. We started as one of the first companies providing plasma testing, LEP, light emitting plasma testing, from the 4101 light engine to the 4102 from Luxem, and now we've seen plasmas go from a 300 watt level to a 270 watt with the same output, so they just got more efficient. But you've done some really cool testing with both the plasma and the LEC. Can you talk a little bit about the testing that you've been doing?
So many of you that haven't been familiarized with the LEC, it's a light emitting ceramic, which is essentially a ceramic metal halide, which is commonly found in the retail industries. However, this one has been tuned for horticultural production, and it's actually, instead of being the traditional 250 and 400 watt, it's now at the 350 watt level, while still has a very high output, very broad spectrum. So like you had mentioned, Ryan, it's great for full spectrum, flowering as a supplemental light, or an unbelievable vegetative lamp.
Now, the traditionally LECs, or let's say ceramic metal halides in the past at 250 watts, 400 watts, they've been around for a while, but they were really designed for a true CRI, color rendering index. Really, in the grow world, who cares about CRI? We hear growers talk about CRI all the time. CRI is really the true color rendering of what you would see in natural light versus what the lamp's putting out.
Right.
And that's important when you're going to buy a painting, because you want to know it's going to have those true colors that you're looking at when you buy them in your house. You're buying clothes, exactly. You're buying furniture, but not for growing plants. So let's take CRI out the window. But what we would like to talk about is the new ceramic metal halide, or let's say LEC, light emitting ceramic, that we've been testing. So this Philips LEC lamp comes in a 315 watt. Can you talk a little bit about the two lamp options?
The bulb was actually made by Philips. It's an extremely high-end, very broad spectrum horticultural bulb. So the most common one when you buy an LEC, it's going to come stock with a 3100 Kelvin bulb. This is going to be the full spectrum bulb, very similar to the plasma. Now, we also have an upgraded bulb option, which is going to be the 4200 Kelvin bulb. This is going to be more favored on the blue side, so it's going to have a little higher ultraviolet radiation, which this one might be a little more favored for a supplemental flowering light, especially for you essential oil producing growers out there.
Not a standalone flowering light though, right?
I mean, it would work well for a flowering light, but you're going to get extremely high quality but very small flower sites. So you might not be overly impressed with the production. However, if you are doing essential oil producing plants, yes, they will give you high quality with less quantity.
Say button nuggets with great terpene and essential oil production.
Yeah, I mean, I would say if I were to choose one of these two to flower under, the better option would be the full spectrum, so the 3100 Kelvin bulb. However, these still are designed for vegetative, or at least as supplemental lights.
Now, we get the LEC option through a number of companies. There's the vertical bulb versus the horizontal placement bulb. What we wanted to go ahead and test is the newer option, which is the vertical placement bulb.
Right.
And so you did extensive testing with the 270 watt light emitting plasma versus the 315 watt LEC vertical operation. Let's talk about that test a little bit.
Well, it was actually really exciting. The cool thing that I liked about them is they have a very similar footprint. Many people talk about the footprint of these, and they're trying to maximize them to get a traditional HID 4x4 that they're trying to stretch. These ones are really designed for like a 2.5 by 2.5, but it's a very focused 2.5 by 2.5 footprint, and it's a very quality light. So especially if you are growing mothers, or if you're doing vegetative growth, you're going to notice very tight internodal spacing, and that's just because of how full that spectrum is.
Really healthy plants, I imagine.
Extremely healthy plants, and like we've talked about in multiple videos with our lighting technologies, with the higher quality spectrum, especially when you have ultraviolet radiation that's hitting those leaves, they're going to have thicker tissue, and so it's going to be a lot healthier of a plant overall, and have a tendency to fend off any pests that may come its way.
So we knew there was going to be a 45 watt difference between these fixtures, being the fact that the plasma is now at 270 watts and the LEC is at 315. So we knew that the LEC was going to have an advantage. Let's talk about the intensity a little bit. What are the intensity differences that we noticed with the 270 watt plasma versus the 315 watt light emitting ceramic?
It's quite a big difference, actually. I mean, what you guys are going to notice after watching this video, we're going to have the data and the spectral distributions published, And it's quite a big difference. I mean, the main similarities is the footprint that they produce and the quality of light. We stretch them as much as a 3x3, but the ideal footprint is still a 2.5 by 2.5. Now the difference really is the LEP, the light emitting plasma, has a much higher quality of light. It's going to have a very broad but a high peak and all across the board from 400 to 700 nanometers, and actually even a little outside that range. And you're going to see, if you look at it in the spectral distribution graph, it's like a big tabletop mountain. It's a big plateau.
It's a true full spectrum.
True full spectrum. Compared to the LEC, which yes, it is full. It has a high intensity from 400 to 700 and slightly outside that range. But you will still see peaks and valleys, and the real reason behind that is because of the gas that they're using inside the ceramic metal halide.
Let's take a look at these two charts together. Okay, so we have the plasma here. You see the full spectrum that you're discussing. But then we have the LEC, which is very close, but you can see that there's little slices of nanometers that are missing, which is very similar to what you're talking about. You know, the metal-halide and argon gas that's superheated in the plasma provides still a more full spectrum light than the mostly metal-halide gas that's inside of the LEC.
Right.
So, you know, obviously we know there's about a 14% difference in electrical draw from the LEC being at 315 watts to the plasma being 270 watts. Let's talk about the actual intensities at particular distances. Can you describe a little bit about the method that you use for the testing the two fixtures?
So because these are really designed for about a 3x3 area, we did them on a 3x3 grid. When, you know, many of our viewers out there are familiar with our testing being done on a 5x5 area, taking an average amongst the 25 points, where every point is each square foot is one given area where we test, take the 25 points and we take an average. For these lights, like I said, they're designed for a 3x3, so that's what we tested them on, is 9 total points. Do we take an average amongst them all? So that way we can actually grade each light. And that way we know where the drop-off is at certain heights, and we can tell where the drop-off is at a certain footprint.
So let's take a look at the LEP. It looks like we tested at 12 inches, 18 inches, and 24 inches.
Right.
We obviously know that 24 inches is a little far away for a 270 watt light. Can you describe a little bit about the test that we're looking at?
So what you're going to notice here is there is actually a pretty big drop off when you get up to the 24 inch level, like you had said, Ryan. So this LEP, the plasma, is actually best designed around 12 to 18 inches. Now, 12 inches might be the most ideal because you see that's where the PAR is going to be at its highest level, but you're going to sacrifice the footprint. So if you're stacking multiple of these plasmas in a room, you're going to notice a very high intensity and a very focused footprint. Compared to if you're trying to maximize the lighting footprint with minimal amount of light, you're going to want to keep it up a little higher, but you're sacrificing micromoles.
You know, I see that, just looking at these tests, that I couldn't imagine having it above a 12-inch level.
No, I wouldn't either.
The intensity is just not there for what most growers are looking to achieve with plant production.
The problem with that, though, is, I mean, when people are using these plasmas as supplemental lights with their HPS are generally 42, 48 if you're using a high intensity commercial DE fixture. But if, say, you're air cooled and you're using them supplemental, you might be as minimum as 18, 24 inches above the canopy. Well, if you have your light at 12 inches above the canopy for supplemental, you're going to be having a pretty large amount of shadow. So most people, when you see are using these LEP fixtures, are still keeping them up right neck and neck with their HIDs, which is kind of an issue because you can see the drastic drop off of the micromoles. So us here at Monster Gardens, we recommend 12 inches to be the most ideal as far as the height above the canopy.
But would be difficult to put into a standard HID lighting without shading out your more intense lights, your HPS. So I agree with you there. And you know, if we were to look at the 18-inch level and we gave a handicap to the LEP over the LEC, being the fact that it's basically has a lower wattage draw, what we do is we increase the LEP, the light emitting plasma, by 15% to give it the same wattage output or wattage draw as what the LEC would have. And I'm only seeing a difference of from 290 micromoles to 333. So I don't see a drastic difference of intensity from one fixture to the next to maybe warrant bringing above 12 inches. Also, what's important to know is that the fixtures run very similar in heat, right? That's you tested the heat of these two fixtures that built up in a grow tent, and you noticed that they had a very similar heat output.
They definitely are very similar. I mean, a lot of times people talk about the plasmas running a little warm, and that's why they actually made an air-cooled option It's really just the light engine, the Luxem light engine that we talked about. That's what's generating the most heat. It's not the actual bulb itself. At the same time, the heat dissipates very quick in a grow room, especially if you have ample air movement. And the LEC is very similar. Based on our testing, I noticed that the LEP and the LEC have a very similar heat output. And it's going to drop off pretty quick as soon as you have air movement. And so it's generally something we don't necessarily have in the question, although they do still generate some heat. But still, they're pretty neck and neck.
You know, I've had growers come and ask me, and they say, you know, I want to get the plasma. I've heard they're cool running. Well, it's cool running in comparison to a 600 watt Metal-halide or a 1000 watt, of course, because of the wattage difference. But let's admit, it's superheating argon Metal-halide gas to a plasma state inside that little tic-tac-sized bulb. So it's getting warm.
It's quite warm.
So let's go ahead and take a look at the LEC testing, because that's going to be a better comparison to what we're looking at with the plasma. So now we have the LEC for you to take a look at it. And there's definitely some differences to notice here. Can you talk about those differences, Steve?
So when we look at the test results on the LEC, especially when you compare it to the LEP, it's quite a big difference. I mean, especially when you go at that 18 to 24 inch mark, which will be the ideal distance above the canopy on the LEC. It's 3.5, almost 4 times the output. However, we had anticipated this with that 45 watt increase. At the same time, the spectrum isn't quite as broad. It's not going to be as full of a spectrum, but the intensity that the light is throwing is
it's a pretty close spectrum.
Yeah, I mean, in my opinion, I like the intensity, especially if you're going to be using it for a mothering light where you're going to need to have that penetration, or if you're using it supplementally with HPS. The distance is going to be ideal, so you still want to have that high intensity with keeping your distance above the canopy.
So I just gave the information on the 18 inch for the LEP in comparison, saying I would never want the fixture to be that high. But what I went ahead and did is I just did a quick calculation with the LEC. I took out 15%, which is the difference of their wattage drop. So I made it more similar in their wattage output. And I'm noticing 841 micromoles over an 18 inch distance, where the LEP is only 290 micromoles. And that's something to definitely take a look at. I mean, Steve said it's quite a bit different in output.
It's huge.
Almost, I would say the LEC is almost like 2 plasmas in total output. You know, and let's talk about another thing, the price point of these fixtures. So we know they're very similar in heat running. We know there's a significant difference in output, but they also have a very similar spectrum, though the plasma is better. Let's talk about the price point of these products, though.
Well, I mean, you're definitely, all of you Monster members out there are going to know that the LEC is going to be quite a big difference. I mean, it's right about half the cost, if not a little bit more than half.
And replacement cost, you know, the problem with the plasma is there's still not a lot of replacement options for those the tic-tac size bulbs, as well as the driver. And you know, the LEC, it's easier to get a hold of these lamps.
It is.
Hopefully Philips doesn't pull out of the lamp market as they did with the DE lamps. Knock on wood, I don't have any wood around me, but yeah, no, it's really important for growers to know that even with the light emitting ceramic through Philips, you know, Philips did pull out of the horticulture market for the DE lamps, and that's why Gavita, Papillon, all these other companies scrambled to get different lamp brands for their fixtures, but Philips still provides some of the best lamps in the industry. So it's definitely a conversation point to discuss.
The big thing also about the lamps themselves, I mean, the LEC, the ceramic metal halide bulb by Philips is still rated for 10,000 hours. I mean, that's a long time. And the same thing is for the LEP, that's also 10,000 hours. When you look at them apples to apples, especially if you compare costs, I mean, it's kind of a no-brainer.
So what you're looking at is still an annual replacement cost on the lamp. And the lamp for the LEC is obviously somewhat pricey as well.
It is.
So it's something to take into account with your cost. So we went over the 4200. Let's take a look at the 3100 Kelvin LEC. Was there a significant difference in output with 3100 LEC lamp?
So when we compare the micromole output from the LEC 315 at the 4200 Kelvin bulb compared to the 3100 Kelvin bulb, with the full spectrum, you're going to see a slightly higher micromole output, and this makes sense. I mean, the spectrum itself is more broad. And so with that said, more of the light falls between 400 and 700 nanometers, considering a higher micromole count. So it does make sense. However, when you do look at the 4200 Kelvin bulb, if you are using it for UV radiation, the UV that's going to be in the 4200 Kelvin bulb is superior. However, broad spectrum, 3100 Kelvin is going to be a little higher, especially in the micromole count.
You know, it's a minuscule difference, a percentage difference with the intensity versus spectrum. I really see the 3100 still being the bulk of what most growers are going to be going after.
It's the most common one that we sell.
And now know this, so you look at our light testing, we do a lot of light testing here. We do testing before we carry product. It's really the difference of what we try to provide our customer base. But really what's important is to know that our testing is slightly different for our micromole testing than you might see off a sales data sheet from Gavita or Philips. Most of the testing that's done by lamp companies is done at the manufacturing facility. They do an initial light sphere test, and that's why you see really a lot of consistency in regards to the micromole output of DE lamps and other things. They do a really, really simplified test, but in a high quality light chamber. We do a little differently. So what growers are going to notice, they're going to look at our micromole count, they're going to be like, wow, we're at, these guys are testing this at 1,000 micromoles, it's going to burn my plants. Really what real growers know is that about 800 to 950 micromoles is what's typical for maximum flower production before you go to a negative effect on the plant. That micromole perception is based off of the standard testing that's done by lighting companies, where they take an initial lamp off a run and they'll do an actual light sphere test, a really quick contact time. But at Monster Gardens, we do a little difference of the way we do our micromole test. We do it in the way that you're growing. We do it as the grid in a grow room. So we take a 4x8 grow room and we take a 5x5 grow area, and we really do our micromole testing in those chambers because those are complete relativity to how you're gardening. The light sphere works really well, and a lot of our manufacturing companies do that, but our test is done slightly different. But I also see, noticing these numbers, is I really wouldn't put the LEC higher than 18 inches. I think that's a really good, even though we tested 24 inches in both the plasma, I really see the 18 inches a great place, or even 16 inches with the LEC.
Yeah, that's the ideal. I mean, not to mention, like we were talking earlier, as soon as you raise it up higher than that, you kind of take the intensity away, and you might be doing that to get a little larger footprint, but you really don't want to sacrifice losing those micromoles just for an additional footprint. If you have to, you can always use a second 315, or you can even use the new 630 that they're coming out with for a little larger footprint, because we really try to encourage people to keep them at 18 inches because that's where they're going to be driving the most ideal amount of output and getting the most vigorous amount of growth.
So where I see the best placement off my experience with these fixtures is really in veg, mothering, with LEC specifically because of its intensity better than the plasma. But your mothers are still not going to be, human size, adult size mothers. You're probably going to be looking at mothers that are still maximum at the 4-foot level. But let's talk about the LEC world. I know there's some new stuff on the horizon. So Steve, we have in the LEC world a new LEC fixture that has come available.
Yeah, this one's actually really exciting. I've been waiting for this one to come out. It's a 630. So they basically took two 315 drivers, two 315 bulbs, and essentially married them together in the same reflector. And it's going to be a little more rectangular shape, which is, compared to the 315, is a little more of a square shape. So it's going to be giving you a little larger footprint. However, you still don't want to be using this as a standalone flowering light. People think,
unless you're just growing for essential oil production.
If that's all you're growing for, if you're not growing for quantity, you're growing for quality, this is going to be an outstanding light. At the same time though, many people equate more lights to more flowers. Well, this light is really designed for broadening your spectrum or just driving vigorous vegetative growth.
Yeah, I see the 630 as a great opportunity for those guys that are vegging large plants or vegging, let's say, a large room of plants. They're trying to get less fixtures in that given room, or mothers. I mean, it's an awesome mothering fixture. Now, if you need the intensity of 1,000 watt, the Metal-halide is still the best opportunity. But the 630 is a great bridge for those guys that are doing a lot of R&D or that are trying to get a great veg lamp. I really see it there. And let's just admit that reflector is the size of a Magnum or a Raptor. So again, if you're looking to set up a greenhouse, you're not going to be looking at really many of the options that we've talked about today.
They're going to block out too much sun.
They're going to block out
that's your
too much
main
sun.
light source.
But if you're a warehouse garden, closet garden, garage garden, what's more typical for people that are not growing in a greenhouse situation, you're going to notice that these fixtures would work really well as a vegetative piece. Noticing that you have a full spectrum light, regardless if you're looking at the 4200 or the 3100, I still kind of consider them both full spectrum.
Now, a little thing I do want to throw in, just because I know a lot of our gardeners out there are growing in tents, please make sure and reinforce your tent with the 630. It is a pretty heavy unit, And we always tell people to tape the joints in your tent.
What Steve's bringing up is to make sure that your tent.
Just reinforce it. The last thing you want to do is come into your garden to check on your babies, and then all of a sudden your 630 is sitting on the ground.
Cool. Well, thanks for taking a look at our video or our podcast if you're listening to this. And again, don't hesitate to give us a call at monstergardens.com.
Thank you.